Okay, so today we're going to look at something that's called an electric field. In this video lesson, you will have to be able to describe what an electric field is, and this is the description here. We'll talk about this later. And then you will have to be able to know what are the direction for the field lines, and also you need to be able to draw the field patterns. So let's start. The law of electrostatics states that opposite charges will always attract each other, and while similar charges will always repel each other. It only occurs if the two charges are close to each other. The force of repulsion or attraction can be represented by an electric field. An electric field is basically a region where an electric charge will experience a force. So just like gravitational field, even electric charges have their own field. So it's basically a region around the charge where if you put another charge other than itself into the region, the other charge will experience a force, whether there'll be an attractive force or repelling force depending on the charge itself. So here I have a space here, and there's nothing in yet. So I'm going to put a positive charge in this space, and you will see what happened. And when you put a positive charge in this space, it then produces its electric field. And you can see for the positive charge, the field lines, they are all pointing away from this charge here. So that means if you put, let's say you put a positive charge here, it will follow the direction of the field line. So there will be a force there will be a force away from the positive charge. If you put it here, so that this positive charge will move that away as well. Okay, so field lines just are there to show the direction of the force acting on another positive charge if it's were to put in that field. So this is the field line for the positive charge. As for the negative charge, it's the opposite. The field lines are all pointing towards it. So you can see. Another thing to note is that the closer you are to the charge, the stronger the force is. So if you are far away, you can see here, the force gets weaker and weaker. So that's another important thing to note. This is what they look like. So make sure when you are drawing them, you know the direction of the field lines. For positive charges, the field lines are pointing away. And for the negative charges, the field lines are pointing towards the charge itself. If the two charges are placed close together, the field line will interact, and it will look like this. So you can see the field line will look like this. And then what's going to happen is that they're going to attract each other. You're going to need to be able to draw this for your exam. And if there are similar charges, then these are what the field lines look like. So this is two negative charges close together, and of course they will repel. These are two positive charges close together, and of course they will repel as well. Take note that the direction of the field lines still follow the rule. For negative charges, the field line direction is pointing towards it. For the positive charges, the direction of the field lines all pointing away. Okay, so this is what it looks like when the charges repel each other. If you have two electric plates, that means if you have two metal plates that are charged, so if you have a positive and negative, it will look like this. If you have a negative and positive, it will look like this. And the rule still applies. So the field lines are pointing away from the positive charge, and then it point towards the negative charge. So let's do an example question. So the example reads, a light conducting sphere is positively charged. It hangs vertically on an insulating thread. When a metal plate is on an insulating stand is brought near, the sphere is immediately deflected as shown below. So in the beginning it was at rest, but then when you bring this metal electric plate close, it then begins to be deflected and have this sort of position here. Okay, so that's before and then after. Question A. What possible reason can there be for the deflection of the positively charged sphere? So why does the positively charged sphere moves in this manner? And that is because the sphere is deflected because the metal plate must be positively charged, and similar charges will always repel each other, and that's why it has that movement there. Question B, how does the movement of the ball illustrate the existence of electric field? So they're not touching each other. So how does this prove that electric fields exist? And the answer is the movement of the ball comes about without any physical touch by the plate. The ball moves away from the plate on its own. This shows that there is an invisible force acting on the ball, and there are electric fields between these two, and they are interacting with each other. That's why there is a repelling force acting on the ball. All right, so to summarize this lesson, we looked at electric fields, what they are. Make sure you are able to draw the field patterns for positive charge, negative charges, and also when you have these charges together, so when we have a positive and negative charge, they will attract. What does that field line look like? You need to be able to draw that. And if you have two charges that repel each other, you need to be able to draw those field lines as well. In the next lesson, we're going to look at electric hazards and how electric hazards can be dangerous to humans.